Hello and welcome to my presentation about the cloud capabilities in GeoDict 2023. My name is Rolf Westerteiger. I'm a senior software developer at Math2Market and I'm responsible for the technical realization of our cloud solutions. Now, as a motivational example of why you would want to run your simulations in the cloud, we did a material development project with a customer where we ran 24 individual simulations, each of them on a machine with 48 CPU cores and 348 gigabytes of RAM. Each simulation ran on a processed synchrotron sample with 2400 by 2400 by 2100 voxels. And the whole package of simulations finished in just over 29 hours instead of the 3 weeks it would have taken running sequentially on a local machine. Now, before we dive into the technical demonstration, let me give you a quick overview about the options for running GeoDict remotely or in the cloud. First of all, of course, there's the remote desktop and mobile office setup, where you log in remotely to a compute server or workstation within your company intranet. This is included with every GeoDict license. Second, there's the GeoDict Cloud, which is the first cloud solution that I will present later, which allows you to submit jobs directly from your local GeoDict user interface. This does require a local license for you to use your local copy of GeoDict, and it requires a prepaid or pay-per-use licensing scheme for the cloud aspect. And third, there's the software as a service solutions, which does include the Math2Market Cloud, which is the second cloud solution I'm going to present, which gives you a managed remote desktop. And again, here we can offer prepaid and pay-per-use schemes. And there's also the option of using a managed remote desktop by a third-party provider, whereas the floating license server would then be managed by Math2Market. Here we can arrange a special cloud license or again offer prepaid or pay-per-use schemes. The first feature I want to present to you is what we now call the GeoDict Cloud. I've already presented this feature in a prototypical stage on the last user meeting, but now it is fully integrated into GeoDict 2023, including job management and downloading of the results once the simulations are finished. On the right-hand side, you can see the normal Floatic module, and as you know, there's a run button which will execute the simulation on your local machine. But now you will also find a run in cloud button which will submit the job to the cloud and run it in the background. This also allows you to run parameter studies in parallel if you have a GeoPython macro with variables. And there's a wide selection of hardware available to run your simulations, even with machines up to, I think, 4 terabytes of RAM. In this segment, I want to show you the fully integrated GeoDict Cloud functionality in GeoDict 2023. I will start by creating a small fiber structure using FiberGeo, which you can see here. At first, I will run a local flow simulation, as usual, by going to Predict, Flowdict, to Stokes-Brinkmann here, and clicking Run. Now this will take a few seconds. Of course, in reality, you would use this cloud functionality with much larger structures. But this is only for demonstration purposes. So now we can see the result here, the permeability tensor, for example, and we can also load the flow fields and visualize them as usual. But now let's pretend that this was a very large structure and you either do not have the local hardware resources or the patience to run the simulation on your own workstation. Let's have a look at the user interface on the left-hand side. We clicked the Run button before, which ran the simulation on our local machine. But now in GeoDict 2023, you will also find a Run in Cloud button next to that. Now let's see what happens if we press this button. We get a new dialog here where we can set some parameters for our cloud simulation. For example, a case name. I will just call this my first cloud flow simulation. And there are two options here which are currently not changeable. I will explain this in detail later. But this option, Upload Current Structure, means that it will upload the structure that is currently in memory to the cloud before running this command, which is necessary to run a flow simulation. Here we can select a GeoDict version, and here we can select our license. And maybe most importantly, here we can select the machine that we want to run the simulation on. You have a very large selection of machines here with up to 4 terabytes of RAM, as you can see down here. So you should be able to run any type of simulation with this cloud interface. Let's just pick a modest machine with 4 cores and 16 GB of RAM for now. Click OK. And now I will click on Run. And GeoDict will automatically open the GeoDict Cloud Projects window here, as you can see, which shows our cloud job that we have just submitted with the status of unfinished. Now at this point the job is submitted to the cloud and I'm free to close this window or minimize it and keep working with my local GeoDict instance. For example, I could go back to FiberGeo and create another structure with a higher solid volume percentage, for example. And I can go back to FlowDict and submit another cloud job. Another flow simulation. I'll just call this my second cloud flow simulation with the same machine type that we had earlier. I'll click Run. And now there will be another job. Now the big benefit of this cloud solution is of course not only that your local workstation is free for interactive use, but also that all of these jobs that you will submit here are executed in parallel. So for example, at the end of your workday, you could just submit 10 jobs, one after the other, go home, and in the next morning you can fetch your results from the cloud, and the simulations will only take as long as a single simulation would take on one machine. I'll click Refresh. And now we can see that both our simulations have finished. This is my first Cloudflow simulation and my second Cloudflow simulation. And now what we can do is we can go to the simulation and say download results. And here you can see the result data that is stored on the machine. The results for this concrete case are in the subfolder My First Cloudflow Simulation. And I will just select all of these, click OK, and I will download those results there. Now I will do the same with the other results. And now I can close this dialog and look at my results in GeoDict by opening the GR files. So this is the first one. And this is the second one. And now I can see and, for example, compare the resulting permeabilities here from the two simulations. Now, as I mentioned earlier, this might already be enough to get a huge productivity boost for many users, but if you want to use the power of GeoDict automation, you can also run whole parameter studies automatically in the cloud. And I will show you this now. I go to the macro dialog, execute macro script. Here I have prepared a macro. What this macro does is it generates a fiber structure similar to the one that we've seen before, and it runs a flow simulation right afterwards and stores all these results. So we can see here that this macro has two parameters, the solid volume percentage of the whole structure. So basically this is 90% pores, and a relative volume percentage of the bigger fibers. So this is 50% bigger fibers compared to the small diameter fibers. Now what we can do here is set up a parameter study by giving an array of values. For example, we have solid volume percentage 10, 20, 30, and volume percentage 25, 50, 75 for the fiber ratios. And we set both of these to vary, which means that it will execute a cross product. So it will simulate all combinations of values here, of both these parameters. Click OK. And now if we were to click Run, all these variations, the whole parameter study would be executed sequentially on the local machine. But instead we will click Run on Cloud. And we'll end up with a similar dialog as before, but notably there's a table down here, and this table shows us all the individual cloud jobs that will be submitted. We can see here that solid volume percentage is varied between 10, 20 and 30, and the big fibers volume percentage is varied among 25, 50 and 75. And this gives us a total of 9 cloud jobs. Again, we can define a name here. Let's call this my first cloud parameter study. And now we can actually select these two options, upload current structure and upload current project folder. Because this macro, as I said, generates fiber structure and then runs the flow simulation, there's no need to upload any structure from memory here. And neither do we need to upload any external files here. So we can now just go and click run at this point. This will submit the jobs to the cloud. And now we will see our new project up here. And now we can see that below the project header, we can see all the individual cases that we have submitted, all the 9 cases. And each case name will be augmented by the variable values for this case. So we have the case name that we specified, my first cloud parameter studies. And then we have the variable values, GDSVP equals 10, GD large fibers volume percentage equals 25. Now we can see that it's actually already starting the machines for the cloud simulation. I will fast forward this a bit. And now, a few minutes later, we can see that all our simulations have finished. I can now download all of them at once by selecting the project here, clicking download results. I'm interested only in the result folders here, the ones which have the variable values. And I will go to download and I will make a new subfolder, study. Select that. And now we'll download the results. And now I can go to the file manager, go to that new folder, and I see all my result directories here. For example, here for the GDSVP 20 and large fiber volume percentage 25. There are my 2 result files, the one from the structure generation and the one from the following flow simulation. The second product I want to present to you today is the so-called Math2Market Cloud, which allows you to run virtual workstations in the cloud straight from your web browser. On the left-hand side, you can see the so-called dashboard, where you can see an overview of all your running virtual workstations, as well as your stored project data. And the advantage of this solution is that a local GeoDict installation is not required, and we only have minimal hardware or software requirements. Even a laptop with a web browser or a tablet should be enough to use GeoDict remotely on even the most powerful machines. Those of you who have participated in the workshops in the User Meeting 2023 will have already seen this interface. This is the Math2Market Cloud dashboard, and it allows you to start virtual workstations in the cloud. It consists of 2 tables. This table shows you all the workstations that are currently running, and this table down here shows you your stored result data. This result data you can download by clicking on zip files here, and you can also upload zip files from your local machine to this storage basically. I've already done this for CT scan of an air filter here, and I will now start a virtual workstation which has this data in the project folder by clicking the Start Workstation button over here. And now one thing that was not possible in the workshops is with a production environment, you can theoretically decide which kind of machine you want to start. For this purpose, I will pick a machine with 16 cores and 128 gigabytes of RAM. As you can see, you can get machines up to 1 terabyte of RAM with 64 cores. Now we can see that the machine is starting here. And at this point, I will fast forward it a bit. This usually takes about 2 or 3 minutes to boot up the machine. Now after about 2 minutes, the machine has booted and we can get the password for logging into the machine by clicking on Show here. Then I will just select and copy that password. Then I will click the Connect button. This opens a new tab in the browser where we can paste the password. And we end up with a Linux desktop which has GeoDict pre-installed with your corresponding license. And I double-click GeoDict. And now as a first step I will use import geo to open the GRW file that I've uploaded, which I can find here. This is the contents of the zip file that I had uploaded. Go to image processing. And now, as a first step to make this dataset a bit more manageable, I'm going to downsample it by a factor of 4, just for this demo. Then I will perform a quick segmentation. Something like this. And then I'll click Create Segmentation over here. Close the dialog. Close the result viewer. And now I will remove those noise components using Process Geo. Lens. Okay, and now we end up with a cleanly segmented structure here. And now, last but not least, I want to run a flow simulation in the Y direction. For this purpose, I will set this pore material to be air by clicking here to constituent materials. Select air for the pore material. And now I will go to Predict, FlowDict. Make sure the computation direction is set to Y direction here. And click Run. And now this will run the flow solver, and at this point I can basically close this tab, the machine will continue running, and I can reconnect this interface anytime that I wish to. Now at a later time I can log in back to this dashboard, again copy the password, connect to the running machine, and I'm back on the desktop and I see that the flow simulation is finished here. That the permeability tensor has been computed for the Y direction. Now I can actually load the flow field here. And here we can now see the distribution of the absolute velocity throughout the structure, for example. You can also visualize that in 3D. And actually clip into the structure and look at our result. Now if we're satisfied with the result, we can actually go and upload that result to our dashboard in order to download it back to our local machine, for example. For this purpose, I will go into the File Manager, go to my first GeoDict project. I'll just quickly make a new folder, Upload. Copy the flows, only the flow simulation results there, which does include the segmented structure. Now I'll right click on Upload, select Copy Folder to Dashboard, and call it Air Filter Flow Simulation Result. Now it will upload the flow fields, the GDR data, and the segmented structure. And now I can actually go back to the cloud dashboard over here. And I should see within a couple of seconds, I should see my result file over here. At this point, I can close this tab and shut down the virtual machine by clicking the Terminate button over here. Now, as you can see, the instance is shutting down. And I can, for example, download the result that I've just produced by clicking on the zip file. As you can see, these are the flow simulation results, which I could now, for example, open in my local GeoDict version. Or I could also go and start another workstation with that data and continue working with those results in the cloud. In conclusion, I have presented two different cloud solutions that Math2Market now offers. First, there's the GeoDict Cloud, which allows for batch processing and starting jobs straight from your local GeoDict GUI, and allows you to run whole parameter studies in parallel with a few clicks. Second, there's the Math2Market Cloud, which provides interactive workstations in the cloud with no need to provision your own hardware. A very minimal set of hardware is needed, and it can be used from anywhere with almost any device. Both solutions offer a wide variety of hardware to choose from for even the most demanding simulations, which also includes GPU support, for example, GeoDict AI and for image processing. And beyond those two offers, we are ready to support you in running GeoDict within your own existing cloud setup. And with that, I'll be ready to take your questions. Thank you.